the AQA AS Maths papers from May 2018, paper 1. We're on question 9, which is all about differentiation from first principles. And we're told we've got some sort of table here, and the table looks something like this. I have an x, f of x, h, x plus h, f of x plus h, and gradient for a number of different points. And we're starting, these are all off a curve, which start at 3, -6, and they go as far as 3 plus h and f of 3 plus h. And that's what I get. We're told the function happens to be f of x is x minus x squared, but that's not especially relevant straight away. It will be later. So that's going to be f of x equals x minus x squared. And we're given a few numbers here. We're going to look at the second one straight away because that's what the first question asks about. That's 3, that's -6, h is 0.1, so x plus h is 3.1. f of x plus h, we're told, is -6.51, and we're told the gradient is -5.1. And the question we're asked straight away is, show how the value of -5.1 has been calculated. Well, what we're doing is to say when we have a gradient, we have some point here, which is 3 and -6, and some other point here, which is going to be my new x, which is x plus h, and f of x plus h. And those are my coordinates for that point over there. And the gradient then is going to be that height divided by that distance. That height then is going to be f of x plus h minus the height of this, which is going to be -6. The gradient is going to be that divided by how far is this? Well, that's going to be x plus h minus the 3, which is going to be the value of h, which is 0.1. And I can put those values in from here. So the gradient then is f of x plus h, which is -6.51, minus -6 makes it +6, all over 0.1. You can see that that's going to give me -0.51 over 0.1, clearly giving me 5.1 negative. So that's how I get that gradient there that I'm asked to find. We're told to complete the third row of the table above. And by looking at it, we can see that x isn't going to change. That's still going to be 3. F of x is still -6. H in this case is going to be 0.01. So x plus h is those two added together, makes it 3.01. F of x plus h then, well, I'm going to put my x value in, which we said was, x was 3, so x plus h is 3.01. Let's make that equals, because in a minute I'm going to do my x value, which is the answer, minus the answer squared. That's what that is, and that's a way of putting that in. And I get a value of -6.0501. And the gradient here, well, it's going to look very similar to this. Let's work out the next gradient. The gradient here is going to be, well, I can do it by pattern recognition. That 6.51 becomes -6.0501. Again, we're going to add that 6 to it, or subtract -6, I should say, but add 6. And that's all going to be divided by the value of h, which is 0.01. And if I put that into it, I've already got that value, I can add 6 and then divide by 0.01, which gives me -5.01. So that's going to go here to be -5.01. And that's the gradient of the third row. State the limit suggested by Craig's investigations. Well, as this continues, this is going to come towards 5. So for 9c, it just says to state. So it's just going to be 5. And 9d, using differentiation from first principles, verify the result in part C is right. We'll now have to do a bit of analysis. Let's create a bit of space for ourselves and have a go at that. Differentiation from first principles involves a formula, and that formula is in the data book on page 5 under the title Differentiation from First Principles, rather helpfully. And we're told that f dash of x is equal to, in the limit as h tends to 0, it is f of x plus h minus f of x all over h. That's what it looks like. I'm told that my function is x minus x squared. Let's put that in here. So that becomes the limit as h tends to 0. F of x plus h looks like this. Well, that becomes x plus h. Basically, everywhere I see an x up here, I put an x plus h in instead. It's going to be x plus h minus x plus h all squared minus f of x, which is minus that x minus x squared. But let's be really careful with the brackets here. Let's be very clear what represents what. All of this bit together represents f of x plus h. And this bit over here, x minus x squared, represents f of x. The reason I'm being quite strict about that is that that negative and that negative together are going to make a positive in a minute, because I'm subtracting a negative value. If I wasn't strict about the brackets and what sits where, that would all go wrong. So still we're in the limit that h tends to 0. Let's open up this square bit, shall we? That becomes x plus h. If I open that becomes minus. That's going to become x squared plus 2xh plus h squared. And I pause then because I've got the minus outside. And that's going to be minus a value of x, and then minus plus a negative. Subtracting a negative gives me a positive. So that's going to be plus x squared. All of that divided by h, which gives me in the limit that h tends to 0. Let's smarten this up a little bit and have a quick look, shall we? Well, that x and that x can cancel. I've got an h there, I've got an h there, h squared. I've got minus x squared and plus x squared are going to cancel in a second. I could do that now. I suppose that x squared is going to go and that x squared is going to go because that's actually going to be negative. So let's write that out a bit neater. That h is going to remain minus 2xh minus h squared. Those have all gone, and all that is going to be over the value of h, which gives me the limit that h tends to 0. Let's divide by h, shall we? So I've got a 1 there, minus 2x minus h, which as h tends to 0 then, which basically equals 1 minus 2x. Let's see what happens. At this point, I've got my x was 3 at this point. So that's an algebraic expression for my differential. If I now say at x equals 3, which is where I am considering this to be, f dashed of x equals 1 minus 2x, which is 1 minus twice 3, which is 6, which is negative 5, which is what I got beforehand. And that's what the question asks for.